So we're going to go over exploring one-sided limits. They've given us a few values of x to look at. What we're going to do, and I'm going to zoom in so we can see this a little better, we're going to just talk about them in many different ways we can think about things. Okay, so the very first one they've given us, and I'll highlight it, is at -2. So we're always talking about, when they're talking about their limits in these questions, we're talking about x values. Okay, so there's many ways to write limits and how we can approach them. So the x value of -2 we know is right here. Okay, that's when x itself is at -2, and that's what we're looking at, the x value. So let's talk about approaching that value and the different or same answers we can possibly get. So for instance, one way to write a limit, they usually will say f at x is equal to, g at x is, the limit is equal to f at x. Wrote that backwards. And f at x is, so the limit, that down, the limit when x is approaching 2, the limit of f at x, okay? Move this over a little. So the limit of f at x when x is approaching 2. Now, when we approach 2, there's many ways we can approach it. I'm going to show you the two differences here. If I were to put a negative sign here, that means we're approaching it from the left. In other words, we're at -infinity, and we're heading towards -2. Or if I put a positive sign here, think of that like we're at positive infinity, and we're approaching it from the right side. Okay, so what we're going to do is write the three different examples here. We can have the limit of f at x when x is approaching 2 from the left. That'll be our first example, so we'll call that 1. 2, we'll go the limit of f at x when x is approaching 2 from the right. And we're actually going to look at the limit of f at x when x is 2, or approaching 2. Okay, so let's talk about this. For instance, in the very first one, when we're approaching -2 from the -infinity or the left, we're coming up at it. And what is -2's value? What is its y value? That's what we're really looking at. What is the y value there? 2, yeah, excellent. So we know that it's equal to 2, right? When we approach it from the right, okay, well, there's a big hole here. Well, we're going to start at that hole, so this would be our positive infinity. Think of it like we're coming at the right. And what is our y value here going to be? 2. Okay. And when we're actually at -2, when we're on that value, what is our y value?
2.
2, yeah. So in all three cases, we got 2. Now, one of the things I want you to realize is another thing they're going to ask about is discontinuity and continuity, or if something is continuous. All right. In order for something to be continuous, this must be true. You must have, again, I wrote that first. The limit of f at x as x approaches a must be equal to the function at a. In other words, if we were to plug in the a value into the function, it would have to be true. There wouldn't have to be, it shouldn't have like a vertical asymptote at that point or something like that. Okay, so in this case, yeah, when f at x is approaching 2, we get to -2, and when we're actually at -2, that's the real value. So in other words, this is continuous. Okay, and you can look at it in the graph and see that there's no stoppage at this point. It just kind of cuts right through that point. So we're going to say it's continuous. Okay.
But then how about the other two?
How about the other two? So let's get into those values. Okay. The next one they wanted us to look at was the value of 0. Okay. The value of 0 at x is along this line, we're going to say. And it looks like we have 3 different points for this. So we're going to do the same idea. And we'll jump back and forth. We're going to have the limit as x approaches the value of 0 from the left with f at x. The limit as f at x, or the limit of f at x as x approaches 0 from the right. And the limit of f at x as x is at 0. And that'll help us determine if something's continuous. So when we approach from the left, our 0 value, what is our value looking like it's going to be? 3, that's right. Well, you know what, I'm going to zoom out a little. Good, we can answer it all in one shot. So it looks like we're going to have a value of 3. What about when we're approaching it from the right? Yeah, that's right. See, from the right, we're going something lower, and that's where we do need to zoom in again. So we can see that. When we're approaching it from the right, we're at 1. And what about when we're on 0? What is our value?
0.
Not 0. What's the y value?
1.
There's a filled-in dot right here.
Oh, okay.
So that filled-in dot tells us at that exact point what we are at. Okay? So when we're approaching it from the right, we're at 1. And we're actually at, when x is at 0, our value is 2. And I'll just show you that again. So from the left, the y value is 3. From the right, the y value is 1. And when we're actually on 0, this filled-in dot, that's supposed to be a filled-in dot, it might have been confusing, it's 2. Okay? So in this case, is the limit when we're approaching a equal to f at a? Well, look. When we approach it from the left, we're 3. When we approach it from the right, we're at 1. And when we're actually at 0, we're on 2. Are these equal?
No.
So is this continuous? No. So we'll say discontinuous.
So for like the last one, it's the one that's filled in.
Yeah.
It's not the
But you may have nothing filled in at that point.
then.
And we're going to get into that.
Okay.
Okay. So the next one we're looking at here is the value of 2. So instead of jumping down and redrawing all those limits again, we're just going to talk about them here. What about when we approach 2 from the left? What is our value going to? What is our y value?
2.
2. And when we approach it from the right?
2.
It's 2. Those are good. What about when we're on 2?
It's 2, but it's not filled in.
So if it's not filled in, it's considered non-existent at that point. So because it's non-existent just at that point, is this continuous? No, this is not continuous. Because at this point, it doesn't exist. And it's a very minute point, only at 2. At 2, think at like 1.999 this exists, and at 2.0001 it exists, but at the point of 2, it does not exist there. Okay, so this is discontinuous. So we're just going to focus on the discontinuous now, okay? So that's discontinuous. 4, the x value of 4 being right here, and this was the value of 2. This one's a little easier. When we approach it from the left, what are we getting at?
3.
Yeah, say it's roughly 3. And we're coming at it from the right. And when we're actually on 4,
3.
is this continuous?
Yes.
Yeah, it is. Excellent. Continuous. And finally, the last one being 6. We'll do it in yellow again. Okay. When we approach it from the left, what are we at?
1, no, 2.
2. Yeah, we could say that's roughly 2. When we approach it from the right,
It's 1.
it's 1. When we're on 6,
It's 2.
it's 2. That's right. That filled-in dot represents it. Now, are all of these equal?
No.
So is this continuous at this point? No. So this is discontinuous. Excellent. Okay. So that's the idea of discontinuous, and that's also the idea of approaching things from the left and from the right. And we'll get into actual values of that next. Okay, we're just looking at a graph, so exploring one-sided limits, seeing if things are discontinuous and continuous.